Okay, this is the OCR paper 2 exam. It's the foundation one from last summer, summer in 2017. It's a non-calculator paper. What I'm going to do is talk you through how to do the questions and give you the answers for it. The idea of the video is not that you watch it all the way through, but you skip to the questions you weren't sure on and you look at how to do them. Question 1, start at the beginning. If you ever open an exam paper and you see a bar chart, that's fantastic news because they're usually very easy. First bit, complete the table. Well, Rowan, you've got to fill that gap in there. Well, you can count, it's 6. And then you've got to do the tallies for the other, and it says it's 13. Make sure you put the 10 in 2 batches of 5, then you put the 3. And underneath it says complete the bar chart to show George's results. Get your ruler, get a pencil. Do not do it in pen. Do not try and do it freehand. It must be done with a ruler and a pencil. The only tricky bit here I can see is, for example, on beach, it goes up to 15. So on beach, you've got to make sure you're putting it to 15. If it'll help you, there's nothing wrong with writing these numbers in here. Notice how it goes up in 2s. So 15 is there between the 14 and the 16. Fairly straightforward, 4 marks. Part C, George found 60 trees altogether in the wood. What percentage of the trees were oak? Well, first of all, you need to look back at your bar chart and it will tell you that 18 of the trees were oak trees, and there's 60 altogether because it says there. So you've got to convert 18 over 60 to a percentage. It's a little bit tricky, but what you've got to do is have a bit of a play around with it. So I've just simplified it straight away to 9 to 30, and I've noticed that will simplify to 3 tenths. 3 tenths is 30%. If you're not sure about that, you need to know that 3 tenths as a decimal would be 0.3. So you need to recognize that that is 30%. Question 2, work this one out. Let me explain how I've done it. There's a couple of ways of doing it. First of all, I've ignored the 6. I'll add that on in a bit. So I've just done a half, add 3/4. So you need to get your denominator the same. So I've used 4 because that is the lowest common multiple of 4 and 2. So 3/4 stays the same, and 1/2 is 2/4. So now the denominators are the same. You can add the fraction, and obviously when you add fractions, the denominators stay the same. So it's 5/4, and 5/4 is an improper fraction, so we convert that to a mixed number, which is 1 1/4. And don't forget, we had that 6 at the beginning, so I've added that on, so the answer is 7 1/4. Next one, work out 4/7 of 63. What I do to work out 4/7 is, first of all, you work out 1/7 of 63, which is 9, and you work out its 1/7 by dividing by 7. So if 1/7 is 9, 4/7 is going to be 4 lots of 9, which is 36. If you really don't like that, I always try and show it in some sort of pie sort of diagram. So let me try and do this the best I can. I'm splitting that roughly into 1, 2, 3, 4, 5, 6, 7 pieces, roughly. So 1/7 is 9, 2/7, 3/7, so 4/7. So that's 4 9s are 36. Next one, show that 4/5 is bigger than 7/9. Well, to compare fractions, because that's what you're doing here, you must get the denominator the same. So what do 5 and 9 go up into? They go up into 45. So to get from 5 to 45, you multiply by 9. So because you're multiplying the denominator by 9, you must also multiply the numerator by 9, so it gives you 36. And this one here, how do you get the denominator of 9 to be 45? You multiply by 5, so you must do that to the numerator as well. So there you can clearly see that 36 over 45 is bigger than 35 over 45. That's all you need to do. You've shown that it's bigger. You don't need to write any words for it. Next one, find a fraction which is bigger than 1/5 and smaller than 1/4. So you're trying to find a fraction that's in between those two. And again, it's the same sort of process. You need to find a common denominator, so you can compare them. 5 and 4 both go up into 20. So here I've multiplied the denominator by 4, so you do the same to the numerator. and here I've multiplied the denominator by 5, so you do the same to the numerator, so that gives you 5 over 20. So what fraction is between 4 over 20 and 5 over 20? Well, actually you can't do it because you can't have 4.5 over 20, so there's a couple of options that you could do. You could just change them to be something over 40 perhaps. So this one is something over 40, that would be 8 over 40, and this one here would be 10 over 40. So you can clearly see that in between those two you could have 9 over 40. So that could be your answer. Another way of doing it, you could also put them over something over 200 because you're multiplying them by 10. So that would make that one as 40 over 200. And the other one it would make as 50 over 200. So other acceptable answers would be 41 over 200, 42 over 200, all the way up to 49 over 200. So there's not just one answer to it, but I think this one here is the answer most people will get. Moving on, question number 3. Nathan works out 23 times 12.4 without a calculator. Here are his workings, so hopefully you can see them there. Basically he's incorrect, explain the error he's made and work out the correct answer. Basically let's work out the correct answer, so let's see what he's done. He's done 10 times 12.4 and he said that is 12.40. So this is where he's gone wrong. All he's done is put a 0 on the end because he's multiplied by 10, but that is incorrect. That should be 124. So therefore 20 times 12.4 isn't going to be, because he's doubled that, isn't going to be 24.8, it's going to be 248. Let's look at the next bit he's done. He's done 3 times 12.4. Well, 3 12s are 36. 3 times 0.4 is 0.4, 0.8, 1.2. So 36 add 1.2 is 37.2, which is correct. 37.2. So what you need to do now to work out the correct answer is to add up 248 and 37.2, and let's do that here. 248 and 37.2. Using the old column addition method you would have taught when you were probably about 6 or 7. So there'll be a 2 there. 8 add 7 is 15, so you carry the 1. 4 add 3 is 7, add the 1 is 8, and the 2 goes there. So the correct answer is 285.2, and I'd write a brief sentence here to explain that this is the bit he has got wrong. So draw a little arrow and explain it down there. He's multiplied by 10 incorrectly. The correct answer should be 124. B, 4 friends buy cinema tickets by using this offer. Buy 3 tickets and get a ticket free. So what they're doing is they're basically sharing the cost of the tickets so they're buying 3 of them, getting a third 3, but they're all chipping in a quarter each. So they each pay £4.65. So to get your first marks, it's out of 3 marks, is how much did they pay in total? Well, you add all those up because there's 4 tickets and it's £25.80. And it says how much does a ticket cost. So because you buy 3 and get 1 free, you need to divide 25.8 by 3. What I do, well, I don't like using the bus stop method with decimals in. It does work, but I just don't like it. I've converted this to pennies or to pence. So it's 2,580 and I divided it by 3. I just talk you through this. How many 3s go into 2? Or none, so I carry the 2. How many 3s into 25? Well, it goes into 24 8 times, and there's 1 left over. 3s into 18 go 6, and 3s into 0 go 0. So it's 860 pence, which is £8.60. I think it's fairly straightforward. If you're not sure how to do this second bit, at least get 1 mark by adding up the cost of 4 tickets, 4 lots of £6.45. And you'll get 1 mark for that. Then if you can do the division, brilliant. Next one, question 4. A and B are 2 farms on the map. So they're farms, sheep, dairy, who knows. Use the map to complete the sentences. So the distance from A to B is how many kilometers? So what I've done, I've measured it, and I reckon it is 6.2 centimeters. It's roughly 6.2. I think that's good enough. So each centimeter represents 1 kilometer. So 6.2 centimeters, because 2 centimeters represents 1 kilometer, that is going to be 3.1 kilometers. So the answer to that would be 3.1. Use the map to complete the sentences. The bearing of B from A. And read it very carefully. The key bit is there, is from A. So we are coming from A that way. So we want to know this bearing here, that angle there. So you need to get your protractor. You place it on like that. And I'm not sure how well you can see it, but you start from 0 all the way around to 114. I make that. So it would be 114. Don't forget, bearings are always written as 3 figures. They're called 3-figure bearings. So if the bearing was, for example, 92, you must put 092. But because this is 3 digits anyway, it's fine. Next bit, 2 marks for this bit. C is another farm, and it's 2.5 kilometers from B on a bearing of 230 degrees. So it's coming from B, and it's on a bearing of 230. I'm not going to worry about the distance for now. First thing I'm going to do is work out the bearing from B. So you've got to always start from north. So it's going to be around, that's 180 there. So it's going to be up here somewhere, I would have thought. Now you can either, and there's 2 ways of doing this. You can either draw a line down here, and you can say you know that bit there is 180. So how much more do we need to add on to get to 230? We need to add on another 50 degrees. So you put your protractor there, measure 50 degrees is up here. So it is going to be along this line somewhere, and we're going to find out in a minute where it is. So that is 230. If you're pretty good with your knowing there's 360 degrees in a full turn, and you need to measure this as 230, another way you could have done is to do 360 and take away that 230, which will leave you with 130. So you could have measured that way 130 and still drawn the line down there. But either way, that's good. You get 1 mark for doing that bearing. Now it says it's 2.5 kilometers away from B. So look at the scale. 1 kilometer is 2 centimeters. So 2.5 of those, we need to times that by 2.5 as well. So that will be 5 centimeters. So you get your ruler, and you just measure 5 centimeters down this line, which is there, and you do a lovely cross like that, and you need to label that as C, because it says mark and label. So that is how you get your marks for that one. 5 marks on bearings, quite nice. You should be getting those. Moving on, question number 5. A little bit of work with brackets. Let me zoom in so you can see exactly what I'm doing. Multiply out. When I multiply out, you do 3x times x. Well, it'd be 3, and x times x is x squared. So it's 3x squared. There's an add there, so we put the add in. And 3x times 2y. Well, 3 times 2 is 6. X times y is xy. So surprisingly, you get 2 marks for that question. I thought it would just be 1. So 2 marks for that, fairly straightforward. The next one, solve. You get only 1 mark for this. 7 times what is 28? I think an awful lot of you will look at that, and you're good at your times tables, and you'll realise 7 times 4 is 28, so 4 is the answer. If you want to do it the proper way, and this is how we normally solve equations, you need to get the x on its own. How do you undo a times by 7? You divide both sides by 7. You don't have to show this if you don't want to, but you can do. So x equals 28 divided by 7, which is 4. So the answer is x equals 4. The next one, you've got to solve this one. X divided by 3 minus 2 equals 9. It's 2 marks, so you will need to show some workings for it. The first thing we're going to do is to get rid of this -2. So how do you get rid of a -2? To get it back to 0, you add 2. So we're going to add 2 to both sides. So that will give you, on this side, x over 3 equals, and 9 add 2 is 11. The next bit, you want to get x on its own, don't forget. So how do you undo a divide by 3? You multiply by 3. So that will give you on this side just the x. You've got rid of the divide by 3 because you've multiplied by 3. And 11 threes are 33. So the answer to that is 33. I'll pop that over there. Always substitute your answer back into the top. So let's work this through. If x is 33, 33 divided by 3 is 11. 11 take away 2 gives you 9. You can almost mark that question yourself if you've done that. Next one, question number 6. Let's have a look. Right, x, y and BD are parallel lines. So that is x, y, and that is BD, and we're shown on the diagram that they're parallel. So they don't even really need to write that top line in. It's just words to, I'm not sure why they put it there, because they do show you in the question. X is a point on AB, and C is a point on BD. Again, those facts are in the question, so you don't really need to know that either. Don't you cross out. I'm just showing you didn't need to know it. XB equals XC. So that means that that length there is equal to that length there. Again, you are shown that because you're told it's an isosceles triangle. And in an isosceles triangle, 2 sides are equal, and that is how you mark it. So all that writing at the top is actually told to you in the diagram. So don't worry too much about it. Complete this sentence. Angle XBC. So let's do that. X to B to C. So that means the angle is there. Is 65 degrees because, okay, it's 65 degrees because there's only one mark, and the easiest way of showing that is saying it's a corresponding angle. Because, and I'll show you, a corresponding angle is an F angle. So if we look at this, I'm going to draw an upside down F. So that angle there is the same as that angle there. And you must say, don't say it's an F angle, it is a corresponding angle. So corresponding angles are equal. The next thing, it says work out BXC. So BXC, that is this top angle here, because it goes B to X to C. And what I've done, I'll just make it easy, I've redrawn this triangle here, I've redrawn it down here. Well, obviously we were told that that was 65. So this is what we've got here. So work out this angle at the top. So give a reason for each stage. So the first thing I've done is this. In an isosceles triangle, the angles at the end of the 2 equal sides are the same. That angle there and that angle there are at the end of the 2 equal sides, so they're both the same. So that is 65 and that is 65. You must write this sentence down, by the way, because it says give a reason for each angle you work out. The next angle fact you need to know is that there's 180 degrees in a triangle. So we're going to do 180, take away those 2, and 65 add 65 is 130. So 180 take away 130 will give you 50 degrees. So the answer to that one is 50 degrees. But you must say there's 180 degrees in a triangle. You must remember that sentence about isosceles triangles. You will need it. That sentence, it's in there every single year. So practice writing it and memorize it. Question 7, moving on. There are 20 coins in a pot. This question is an awful lot of information, so I'll try and take my time on it. There are 20 coins in a pot, and the coins are 1, 2, 5, and 10 p's. A coin is taken at random from the pot, and the probability that is a 1p coin is 3/10. So that means 3/10 of the coins, 3/10 of the 20, must be 1p coins. So 3/10 of 20 is 6, because 1/10 is 2, so 3 lots of 2 is 6. So there's 6 1p coins. You'll get 1 mark for working that out. The next bit, the probability that it's 2p coin is 2/5. So we need to work out 2/5 of 20. That's where I'm getting the 20 from. Is 8. So there's 8 2p coins in there. The total value of the coins in the pot is 57 pence. Work out how many of each type of coins there are in the pot. Well, you've worked out that there are 6 1p coins. We did that up there. And that there is 8 2p coins. So at the moment, obviously 6 1p coins is worth 6p. 8 2p coins is worth 16p. So at the moment, we've got 22 pence. And we have used up with 14 coins. So that means there are 6 coins left because there's 20 in total. And because they add up to 57 pence, those 6 coins must add up to, well, they must be of value 57, which is the total, take away 22 is 35 pence. So how can you make 35 pence out of 5p's and 10p's? You can have a little bit of trial and error with this one. I'm just doing it now. I'm thinking if we have one 10p, we have one 10p, and we have 5p's, that will give you 10p, and that will give you 25p, and that adds up to 35 pence, which is how much we want. So to finish off, there are 6 1p coins, there are 8 2p coins, there are 5 5p coins, and there is one 10p coin. Just double check that adds up to 20, which it does, and make sure your coins add up to 57 pence, which it does. It's a tricky question that, but if you take your time, do it step by step, it's a very doable question. Question number 8, evaluate. That's one of those words they use in maths exams. It's just making it a little bit too complicated. It basically means work out. So work out the square root of 121. Obviously it's non-calculator paper. You're expected to know that 121 is a square number, and it is 11 squared. So the square root of 121 is 11, because 11 times 11 is 121. The next one, 4 to the power, and this is a nasty one here, 4 to the power minus 2. I'm going to tell you a trick here. I'm not going to get into the details of it, but all you do, ignore the minus. 4 to the power of 2 is 4 times 4, so it is 16. And if you ever see a minus on the index number, all you do is do 1 over whatever it was. So the answer is 1/16, so it was 1 over 16. I'm going to show you another example of that now, just so you're with me on it. Let's say the question was evaluate 5 to the minus 2. Well, what you do is do 5 squared, which is 25, and because it's there's a minus there on the index number, the answer would be 1 over 25. So that is how you do them. It's well worth remembering. You get 1 mark for it in the exams. Fairly simple if you can remember it. Next one, work out. Okay, well, it's a bid mass question, I think. What you do, you need to work the brackets out first. So we're not going to do the squaring bit. We'll do that later. Your bid mass stuff. So you do your brackets first, which is what we're going to do. Then you do your index numbers, but we're going to do the brackets first. So inside the brackets, you've got a subtraction and a multiply. So it goes brackets, index numbers, divide, multiply, add, subtract. So we're going to do the multiplying first. So 3 times 2 gives you 6. So you're basically left with 9 take away 6. So 9 take away 6 gives you 3. So in the brackets is worth 3. So we need to do 3 squared, which is 3 times 3, which is 9. So the answer to that question is 9. The next one, fill in the power. So 5 to the power what is 125? Wait, do a bit of trial and error again. 5 to the power 1 is just 5. 5 squared, or 5 to the power 2, is 25, because it's 5 times 5. 5 to the power 3, that is 5 times 5 times 5. So that is 5 times 5. Times that by 5 is 125. So the answer to that is 5 to the power 3. 5 fairly straightforward marks there if you know what you're doing. Okay, question number 9. Lillian works for 7 hours each day for 5 days a week. Before I go too far, what I'm going to do is just zoom in a little bit. So 7 hours each day, 5 days a week. It's fairly obvious. I think they're going to ask, well, you're going to need to know how many hours she works. So all I've done is 5 days multiplied by the 7, and she works for 35 hours each week. You get 1 mark just for working that bit out. She earns £420 each week. How much does she earn per hour? Well, she works for 35 hours, so we need to do £420 divided by the 35 hours. Once we do that division, we can see the answer is £12. That division is a little bit nasty. It's a bit tricky with a bus stop. Obviously, it's non-calculated paper. You can count up in 35s, and I've started writing it down here just to show you that you could do that. And if you keep going like that, and on 35 each time, it'll happen 12 times. So you need to be able to work out 420 divided by 35. Count up in 35s if you're not sure. The next question, it says Lillian decides that she's going to work 7 hours each day for only 4 days a week. Lillian's very lucky to have a job where she's got the option to decide that, but well done for her. Her earnings must have very, very kind employers. Her earnings are to be reduced by 20%, and she thinks that this reduction is reasonable. Well, it is reasonable, and explain why. Well, because 5 days to 4 days is a 20% reduction. If you reduced 5 days by 10%, you'll be knocking off 0.5 days. So 20% would be 1 day. So 5 take away 1 day gives you the 4 days. If you want to show that it's a 20% reduction, you could do 10% of 5 equals 0.5. So that means 20% of 5 equals 1. So that's the reduction in days that she's working. So it is 20%. Next one. How much will Lillian earn working 4 days a week? Well, get your first mark. She's 4 days a week times 7 hours a day. She's working for 28 hours, and she gets paid £12 per hour. So you need to do 28 multiplied by 12. I've used the grid method. The answer is £336. You can use whatever method you prefer. I find that one fairly quick and fairly easy, but there's lots of other simple ones you could use as well. Question number 10. Nasty question this. A square is divided into 3 rectangles A, B and C. So there's your square, it's 4 by 4, and there's your rectangles A, B and C. Rectangle A has a length of n centimetres, so you can see that there. Rectangle A has a length of n, and actually so does B, funny enough. And rectangle A has a width of 2, so there you go, you can see the width is 2. Some people might say it's the height, but either way. Rectangle C has a length of 4, which you can see there because it's the side of the square. Write down an algebraic expression for the width of rectangle C. So the width of rectangle C goes from here to here. So you need to work out the width of this bit here. Well, the whole lot is 4, and that bit is n. So that means if you did 4, take away this bit, you're left with this bit. So the answer is quite simply 4 take away n. Make sure my 4 comes out properly there. So your answer is 4 take away n. The next bit, write down an algebraic expression for the area of rectangle A. Rectangle A is here. Well, to find the area of a rectangle, you do the base times the height, or the height times the base. So it is 2 times n. So an algebraic expression for it is very simply 2n. You could put 2 times n if you want, but show off you know what you're doing and put 2n. It looks so much better. The next bit, it says that all 3 rectangles have the same area. Work out the value of n. Right, so the way I've done this, you're told that all the rectangles have the same area. So what we're saying is the area of A is equal to the area of rectangle C. So I'm going to do this bit up here, but obviously should do it a bit further down. So the area of A is 2n. We've worked that out there. But now we're going to work out the area of rectangle C. So we know from here to here, because we worked it out, it is 4 take away n. So that is 4 take away n. So the area of rectangle C is the height, which is 4, times the width, which is 4 take away n. So algebraically, you could do 4 minus n in your brackets. So you multiply that out, and the area is 16 minus 4n. So that is the area of that rectangle there. And the area of this rectangle is 2n. And because they're the same, we're allowed to write 2n equals 16 take 4n. And now we've got an equation. All we need to do is solve it. Just put a little box around that to show it's slightly separate from what we're doing now. So we're going to solve this equation. First thing we're going to do is get all the n's on one side. I don't like having this negative 4n here. So to get rid of that, I'm going to add 4n to both sides. So that will leave me with 6n equals 16. I want to work out the value of n. That's what I'm being asked to do. So I need to divide this by 6 and divide this by 6. So n equals, by the way, if you've got this far, well done, because this is a horrible question. 16 divided by 6 is really, really nasty. So here's a tip I want you guys to use. If it's non-calculator, 16 divided by 6, you can write like this: 16 divided by 6. So you can write it as a fraction. It's actually an improper fraction, or a top-heavy fraction, but an improper fraction. So we're now going to convert this to a mixed number. So how many 6's go into 16? Well, it goes 6, 12, and that's it. So there's 2 of them. And what's left over? Well, it'll be 6, 12. It'll be 4 left over 6. So it is 2 and 4 sixths, but you can simplify that again to 2 and 2/3. So n is 2 and 2/3, or if you want to put 2.6 reoccurring, you can, but I'd be tempted to leave it as a fraction. So that is part B, 2 and 2/3. Very nasty, but I hope that makes a little bit of sense. Question number 11. The first 5 terms in not the Fibonacci sequence, a Fibonacci sequence, are 1, 3, 4, 7 and 11. First of all, if you don't know what a Fibonacci sequence is, I'll quickly explain it to you here. The way this works is you add the 2 previous numbers to get the next number. So for example, 1 add 3 is 4, 3 add 4 is 7, 4 add 7 is 11. So the next 2 numbers in the sequence are 7 add 11 gives you 18, and 11 add 18 gives you 29. So they're the next 2 numbers in the sequence. Next one. In a different Fibonacci sequence, the 4th term is 31 and the 5th term is 50. Work out the first term in this sequence. Now, what I've done, look, that's your 4th, because that's your 1st, 2nd, 3rd, 4th and 5th term. I've done it like this to make it easier. So basically, what do you add to 31 to get to 50? And if you want to cheat, not cheating, but it's maths, but you could do 50 take away 31. Anyway, in there it would be 19. And now you can do a very similar thing. What do you add to 19 to get to 31? Well, you could do the subtraction, but the answer there, I believe, is 12. And on the last bit, what do you add to 12 to get to 19? It will be 7. So the first term in the sequence is 7. If you know what a Fibonacci sequence is and you're used to it, it's not too bad. Okay, the 2nd and 3rd terms in the following Fibonacci sequence are x and y. Write down algebraic expressions for the 1st, 4th and 5th terms. So you get 1 mark for each, I'm assuming here. So do this one at the end. Let's do these first because it's a bit easier. So it goes blank, x, y, blank, blank. So this one here has got to be these 2 added up. So all it is x add y, because you've added the 2 previous terms. And the next one has got to be y add x add y. So that will give you an x, and it gives you 2y. Because y add x add y is x, and 2 lots of y. This one here is a little bit tricky. I'm going to show you a little tip here. If you notice, to get the 19, we basically did this number, subtract this number to give you that number. So 50 take away 31 gives you 19. Apply that theory down here. Y take away x gives you that one there. So what we've done is 50 take away 31 gives you 19. Y take away x is y take away x. Bit fiddly that one, but you can certainly pick up some marks on it. Question 12, moving on. Farmer has a field that is in the shape of a trapezium, and you can see it below. He measures the field so he can work out the area. It's very sensible, and he puts his measurements on this diagram of the field. So there's a handy diagram. Oh, the farmer's very good at maths. He's even put right angles in. He's very good. He's rounded his measurements to 2 significant figures. Give a reason why he may have done this. It is to make the area easier to work out. So it is to make it easier to work out the area. He could have put exact numbers on it. For example, that might have been 183.25 meters, and that could have been 149.98 meters. But it's getting a bit tricky for a field, so he's rounded to 2 significant figures, which is fine. The field produces 6,400 kilograms of wheat per hectare. 1 hectare. Basically, look, I wouldn't bother reading too much of this stuff here. You've got to work out the area of this field, and then we'll worry about the stuff afterwards. So there's 2 ways of doing this. First of all, you need to know how to work out the area of a trapezium, and I've drawn a trapezium here. There are your 2 parallel sides, and it is A add B, so that's the 2 parallel sides added up, divided by 2, multiplied by the height. But for this one up here, and I don't like saying this, but if you're really stuck, you could actually split it into a rectangle and a triangle. So you could work out the area of this bit here by doing 150 multiplied by 180. If you're struggling how to do that non-calculator, I'll be tempted to do 15 times 18 grid method or however, and put the 2 noughts on the end. Then you work out the area of a triangle, and you need to know that length there. So because the whole lot's 220, that's 180, that length there has got to be 40. So the area of that bit would be base times height divided by 2, 40 times 150 divided by 2. And if you add those 2 up, you'll get the area. So you can work that out however you want. I've done it down here using this method. I'll quickly show you my numbers. So I've done A add B, so 180 add 220, that gives you 400. I've divided that by 2, which gives you 200, and 200 times the height, so 200 times 150 gives you 30,000. So it's 30,000 meters squared. You've probably got about 3 marks for doing that, to be honest with you. So it says 1 hectare is 10,000 meters. It's 30,000 meters, sorry, 1 hectare is 10,000 meters squared. So 30,000 meters squared will be 3 hectares. It produces 6,400 kilograms of wheat per hectare. So because it's producing 3 hectares, we need to do 3 lots of 6,400, which gives you 19,200 kilograms of wheat. It's a bit of a fiddly one, but there are quite a lot of marks there, and it's fairly straightforward stuff. You would have been taught this probably in year 8 or 9, so you need to think back and make sure you can do basic area questions. Question 13, moving on. The front and side elevations of a prism with a pentagon as its cross-section. Pentagon as its cross-section. Pentagon has got 5 sides, 1, 2, 3, 4, 5, are drawn on this 1 centimetre grid. So that's the side, and well, that is the side. I've labelled it side, and that is the front, because it says the front and side elevation. Draw accurately the plan of the prism on the grid below. Right, first of all, plan, that's like bird's eye view. That's seeing it from above. So that's what it looks like from the side. This is what it looks like from the front. So from the top, well, you need to notice that it is 1, 2, 3, 4 squares, or back, I suppose, and it is 1, 2, 3, 4, 5, 6 squares across. 1, 2, 3, 4, 5, 6. So I've drawn that there, and what I've done, I've just noticed it goes across straight and goes down. So I've shown that there because that goes all the way across there by doing that line across there. It's a bit fiddly, but 2 marks for it. If you can visualize it, that is great. Part B, it says calculate the volume of the prism. So the volume of anything is the area of the cross section multiplied by the length. So for example, if you're going to work out the area of if you're going to work out the volume of a cylinder, you work out the area of the cross section, which is the circle, multiplied by the length or the height. So we're going to work out the area of the cross section, and this is the cross section here. So we need to work out the area of this bit. What I'm going to do is work out the area of the whole lot, and then I'm going to subtract the area of this triangle I've just sketched on. So the area of the whole lot is 3 times 4. So 3 times 4 gives you 12. And the triangle there, well, we need it for the last question, we need it for this question. It is base times the height divided by 2. So the base of that is 1, 2, 3, and the height is 2. So it's 3 times 2 divided by 2. 3 times 2 is 6, half of that is 3. And that is centimetres squared, so it's that one. So the whole lot is 12. Take away that bit, get rid of it. 12 take away 3 gives you 9. So the area of the cross section is 9 centimetres squared. And the length of it is 1, 2, 3, 4, 5, 6. So the area of the cross section is 9 centimetres squared. And you multiply that by how far it goes across, so the length is 6. So the answer is that 9 6s are 54, and that will be centimetres cubed. That is how you work out volume. Area of the cross section multiplied by the length. Question 14. Here we go. Work out 2/15 multiplied by 15 over 22. Give your answer in its lowest terms. There's 2 marks for this. A little bit fiddly, but we'll see what we can do. When you multiply fractions, you need to know this. You multiply just across. So 2 times 15 gives you 30. And 15 lots of 22. Bit fiddly, that one, so you could use the grid method if you want. Some of you might have some quicker methods for doing it, but I'm just going to show you this so you can see exactly what I'm doing. Multiplying that. So 10 by 20 gives you 200. 5 20s are 100. 10 times 2 is 20. 5 2s are 10. So that will be 200, 330. 1 mark for doing that, and now you've got to simplify it. So what goes into 30 and into 330? 10 goes into both, I suppose. So that simplifies it to 3 over 33. What goes into 3 and 33? Well, 3 does. How many 3's go into 3? 1. How many 3's go into 33? 11. So the answer is 1 over 11. So you need to know how to multiply fractions, basically, and that's how you do it. If you can multiply fractions and simplify, you probably taught it in year 8 or year 9. That's how you do it. Next one. The graph shows Mia's journey from home to university. So we're going to talk you through this distance time graph. So she leaves home at 9 o'clock, and then she travels she travels for, oh, that's 10 o'clock. So that must be, that there is 9:30. So it's split, that's 9:15, that'll be 9:45, that'll be 10:30. Don't be afraid to get these in, make it easy for yourself. And she finishes the journey at 11:30. So she travels for 45 minutes up to 9:45, and she's travelled a distance of 70 kilometres. She has a break for what looks like half an hour, and then she continues the rest of her journey off to university, which is 160 kilometres away from her home. Calculate Mia's average speed for the whole journey. Right, you need to know about this speed, distance, time triangle. Make sure that is imprinted on your brain before you go into the exam. You need to know it. You need to know the average speed, and the way it works is, you want to know speed, you put your finger over speed, and it will say there, look, speed is distance divided by time. So speed is distance divided by time. The distance is 160, because that's how far away it is, and it says at the top, look, 160. And the time is how long it takes, and we're going to do this in hours. So she starts, leaves at 9, and she gets there at 11:30. So that takes 1.5 hours. So it's 160 divided by 2.5. That in itself is quite a tricky division to do, but there are ways of doing it. You could count up in 2.5s if you want, so you could chunk it. You could do 1,600 divided by 25, might be a quite nice way of doing it. I'm going to show you the way I would do it. So first of all, how many 2.5s go into 10? Well, there'll be 4 of them that go into 10, and how many 10s go into 160? There would be 16 of them. So you could do 4 times 16, which will give you 64. So the answer is actually 64 kilometers per hour. But if you can't do the end bit, if you set it up like that, you'll get 2 marks because you've read from the graph and you've used this speed, distance, time triangle correctly. Question 15. Last year, Katie earned £16,200. Her loan repayment was £6,400. I'm guessing it's a mortgage, unless she's borrowed from Loan Shark or something. Katie estimates that the ratio of her loan repayments to her earnings is approximately 3 to 8. Is she correct? Well, 3 to 8. 3 is her loan repayments, so that's £6,400, and 8 parts is her earning, which is £16,200. Now there are lots and lots and lots of ways of doing this. A key word here is that she estimates this to be true. So it's not going to be exact, it's going to be an estimate. First of all, the way I'm going to do it is try and simplify this ratio to see if it is roughly 3 to 8. So we can divide both sides by 100, which will give me 64 to 162. I'm going to simplify that again just by halving, so that will be 32 to 81. Here now, look, 32 to 81. If I were to do a little bit of rounding here and rounded that to 30 to 80, I can simplify that to 3 to 8. So yes, she is correct, and there is my reasoning. I've not written any sentences yet, because most of my marks will be here. What I do is a brief line explaining I've simplified the ratio, and I would highlight that I have from here to here I've done a little bit of rounding to the nearest 10, and yes, she is correct. But like I say, there are lots and lots of other ways of doing that. It's not just that way. Okay, question 17. Rearrange the equation to make x the subject. I've got it all here, and I'll talk you through it step by step. Right, first of all, what I've done, I'll do the workings here. I've written out the equation. So y equals 7x minus 3. When you want to rearrange it to make x the subject, that means you want it so it says x equals whatever it is, okay? So it's a bit like solving. We've got to unpick it to get x on its own. So the first thing I've done is to get rid of this -3 here, and to get rid of a -3 or get it back to 0, you add 3. But of course you have to, like when you solve an equation, you have to do that to both sides. So I've done that. So this side becomes y add 3, and this side just becomes 7x. I want to get x on its own, and at the moment it's being multiplied by the 7. So how do you undo a multiply by 7? You divide by 7. So 7x divided by 7 is just x. And this side, people often struggle. They say they can't do y add 3 divided by 7. Well, all you do is write y add 3 over 7. And that's the answer. X equals y add 3 over 7, or divided by 7. Next one is factorising. Factorise means put into brackets. So x squared means x times x, so you could write it as xx if you wanted, because that means x times x, minus xy. So there's no numbers common here, so it's just the letters, it's just algebraically. And fairly obvious statement, what letter is common in both of these? Well, it's x, so we put x outside the brackets. X times what will give you x squared? Well, x times x gives you x squared. And x times what will give you xy? Well, x times y will give you xy. So it's x brackets, x minus y, close brackets, and it's minus because there's a minus there. You don't need to do this, but what you can do, you just do it in your head, is to check that it's correct by multiplying it out. So this is what I've done here. So x times x gives you x squared, x times y gives you xy, and put your minus in. But your answer, just to make it crystal clear, is x brackets x minus y. 17b part 2, factorize it. It's a quadratic, so we're gonna have to put it into double brackets, this one. I'm hoping you've had some practice of these. The thing to remember is you need two numbers that add up to make 8 but multiply to make 12. This one is a fairly simple one, I'll be honest with you. So they're both positive, so we're going to put in x and x, and we're going to put in plus and plus because they're both positives. So what multiplies to make 12? Well, 1 times 12 doesn't add up to 8. 3 times 4 adds up to 7. 2 times 6, that does add up to 8. So it's x add 2, x add 6. Or you could put x add 6, x add 2. It does not really matter. 2x add 6. Quite often as well, you'll see this question and it will say solve, and it will have at the end an equals 0. Basically you do this step, so you factorize it, and the solution to it would be x is minus 2 or x is minus 6. If you're not sure what I'm talking about, please go and ask your teacher or something. But anyway, it's only a 2 marker, just factorizing it, so that's your answer. The next one, Jenny played 4 games of golf. For these games, her modal score was 76. Right, averages this. So a modal means the most common. So her most common score was 76. And her mean score, mean is when you add them all up and divide, was 75. And the range, so that's the biggest, take away the smallest, was 10. What were her scores for the 4 games? Well, if the modal score was 76, she must have got 2 games, at least 2 games, that was 76. Potentially she could have got a third one that's 76, but we'll work that out in a bit. Now, the mean score was 75, so that means in the 4 games she played, her average was 75. So her total score must have been 300. That is the total score she got overall in those games. So what I'm going to do is to take away 300, take away 76, take away 76. So if you add 76 and 76, that is 152. So I'm going to do 300, take away 152, and that will leave me with 148. So her other 2 games, the scores must add up to 148. Now, we're told the range of the scores is 10. So whatever 2 numbers add up to make that, they've got to have a difference of 10. And my little sort of, not cheat method, but my method for doing that would be to half that. So divide that by 2, that will give you 74. So, you know, she could have got 74, 74, 76 and 76 and had a total of 300, but it wouldn't fulfill the other criteria that her modal score is 76 and the range is 10. So what I'm going to do is take away 5 and add 5, and I'll tell you why in a moment. Now by taking away 5 and adding 5, that's given me a range of 10. There's 10 between it. And also they do add up to make 148, which is what we need them to make. So her scores were, the lowest is 69, the highest is 79, and that gives us her range of 10. Her modal scores was 70, or modal score was 76, and all of those numbers there, they'll add up to make 300, which is what we want, because it will give you a mean score of 75, and that is the answer. 4 marks. Question 18. The population of a village is in the following ratios. So, men to children are 11 to 3, women to children are 5 to 2. Find the ratio of men to women. Give your answer in its simplest form. It's a bit of a nasty one, this, I'll be honest with you, but what you've got to do, because you've got your children here that are sort of common, I suppose, in both, we need to get them to be the same number. So 3 and 2 both go into 6. So what I've done here, look, to go from 3 to 6, you double it, times it by 2, so times that by 2. And this one you times by 3, so you multiply this by 3. So these ratios here, look, 11 to 3 equals 22 to 6. It's the same ratio as you had to start with, but the ratio of the children's are 6. Of the children is 6, so we can start comparing them. So the ratio of men to women will be 22 to 15. And the important part there is getting the children to be the same, so 6. The next one, there are 36 children in the village. Find the total population of the village. Okay, there's a little bit of maths we need to do in this one, but it's a maths exam, so there we go. Right, first of all, we've got the total, so the ratios, go back to the top, were 22 to 6, men to children, and the women were 15 to 6. So if we know that there are 36 children in the village, that means if we divide 36 by 6, that means one part, if you like, is going to be 6. So we're going to add up these two parts. So the men and women will be 37. So if you like, there are 37 parts, and that is men and women, and there are 6 parts children. So if there's 36 children in the village, and that represents 6 parts, that must mean one part is 6. So one part is 6. And how many parts do we have altogether? Well, we've got 37 add 6, so there's 43 parts altogether. So we need to do 43 multiplied by 6. So I'm going to set it out like this. 43 times 6. Again, there's lots of other ways of doing this multiplication, but it's the way I'm going to do it. 6 4s are 24 with a 0 on, and 6 3s are 18. So the total of that is 258. So that means the total number of people in the village, total population of the village is 258. Moving on, question 20. George is the manager of a shoe shop. He samples 50 of his customers and asks them about the one style of shoe they would buy next, and the table shows his results. So George buys 1,000 pairs of shoes with the number of each style based on the survey of his results. How many pairs of sandals does he buy? First of all, you need to make sure that you know he sampled 50 people. The next bit is how many times does 50 go into 1,000? So we're going to do 1,000 divided by 50, and that will give you 20. So that means for each person he is asked, we're going to multiply it by 20, because this will tell us how many pairs of those shoes he is going to buy. And the question is, how many pairs of sandals does he buy? Well, he will buy 160 pairs of sandals, so 160. And it says, write down any assumptions you've made about his sample. The most common one is that you've got to assume that his sample is representative. Things with these samples, he could have asked loads of school children or asked loads of old people. He needs to be asking a good variety of people. Final question. Question 21. Triangles P and Q are right angled. Show that the two shorter sides in triangle P have the same length as the two shorter sides in triangle Q. Well, in triangle Q, your shorter sides are 5 and 12, and in triangle P, one of your shorter sides is 12, but we need to work out this one here. So to do that, we're going to use a little bit of Pythagoras, and even though it's non-calculator, this question works out quite nicely. So we're going to do this one here. Let's label it A, B and C. So A we don't know, so A squared add 12 squared equals 13 squared. So let's just keep moving on down. Show all your workings as you go. A squared add 12 squared is 144. You need to know that. 13 squared is 169. If you don't know that, you need to be able to work it out. So A squared is going to be 169. Take away 144. So that means A squared is 25. And to find A, you just square root it. So that means A is 5. So that length there, A, is 5 centimeters. So the two shorter sides in P are 5 and 12, and the two shorter sides in Q are 5 and 12. So we have shown that. Next one. Explain why the two triangles are congruent. Congruence is a strange old maths word we use. It basically means show that they're the same. And we can show that or explain that they're the same because all the sides are the same length. That's 5 and 12, that's 5 and 12, that's 13. But because these 5 and 12s are the same, and there's a right angle there, this must also be 13. So all you need to say is all the sides are the same length. This was a tricky non-calculator paper, but you're going to get that with the OCR board. But having said that, the grade boundaries tend to be a tiny bit lower than the other exam boards. To get a 4, or to guarantee a 4, I never say guarantee, but you should be looking to get half mark, so 50%, or you might get away with 45%, but aim for 50. To get a 5, which is a good pass, you need to be looking at getting around 60%. On the day, it could be a bit lower, it could be a bit higher, but that's a rough guidance for you to aim for. Good luck. I hope you did. Good luck. I hope you did well on that exam paper.